Hello one and all, this is Jasneet Singh, a.k.a. Innovative Coder from Innovative Coder Workstation, and I welcome you all to the new lecture series for machine learning. So we started machine learning series about like last year, and currently we are continuing that series. So we have covered linear regression till now, and now moving forward we'll be handling logistic regressions and SVM and like further all the algorithms, and we'll be going deep towards the deep neural networks and reinforcement learning and stuff over there. But yes, these video lectures will be posted in around like month or so I think it's a long journey. So starting with this one, I'll be consistent from now on, I assure that. And so topic for this video is handling classification problems. In this lecture, we would be talking about how to handle the classification problem. So currently till now we have seen the linear regression. We'll be talking about what is actually classification and how the classification problems are handled. So firstly, let's roll out the intro. Okay, so in this lecture we want to talk about how to handle classification problems, and starting with classification problems, like starting with the what we have covered till now. We have covered the linear regression part. So a quick backup of what is actually linear regression, because we'll be in this video we'll be seeing like how can we actually handle classification problem using the linear regression stuff, right? But moving forward we'll be using logistic regression, and we'll see the drawbacks of linear regression handling the classification problem, because actually linear regression is a regression algorithm. But if someone asks you, or see logical thinking, like why is actually linear regression a regression algorithm, and why do we moving forward we need logistic regression, SVMs and stuff like the other algorithms, right? So linear regression is a regression algorithm, which means it is good at handling continuous values of y. So if my y, or for y, my y for an x value, let's say we want to predict the stock market, right? Okay, so linear regression has continuous values of y. So if for my y, suppose suppose we have kind of stock market data, right? So the stock market data would be somewhat like 0.6, 0.5, some continuous values, right? So these are kind of continuous values, right? But if we talk about something more kind of a classification algorithm, or kind of classification data, that would be kind of, you can say, take an example of a very basic example of spam and not spam. Yeah, so spam and not spam. So if you take an example of spam and not spam, you would find that for spam we can take 0, and for not spam we can take the values as 1. And this is kind of a binary classification algorithm. So suppose you have kind of 50 data entry points for spam and 50 points for not spam. So at the end you would be having a data, if on a graph you plot the data, you would be having somewhat like a data of somewhat like this. So suppose you have 50 points over here, 50 points over here, right? And when you so for this video we'll be talking about binary classification only, which means only two classes. So suppose we have like 0 and 1, right? And moving forward in in future videos we'll be talking about like multi-class classification. But for this video we'll be talking about very basic stuff, which is binary classification. So what happens in linear regression is, so let's say we have we have x and we have y here, right? You can see the data points I have marked, right? Okay, so suppose we have some x points and some y points, right? So we have plotted our data on the graph. Okay, it's clearly visible, right? So let's draw them, and like we have drawn, and try to analyze. So there are like two classes, right? And one data point can either be in 0 or can be in 1. So we need to find something like a best fit line. So what does that mean? This is like if we get a new value of y, then what we can do is we can get the point from the graph and apply an approximation function over it, so that the y is either 0 or 1 in that case. Talking more about this one, explaining more. So kind of for this data we get this as our best fit line, right? So we get this as our best fit line, and if we get a point, in real time while testing, we get a point. So that point must lie somewhere over here or somewhere over here, right? Now what we can have is we can have this sort of an approximation function, which is kind of y predicted. If y predicted is greater than 0.5, then our prediction, which is the final prediction, would be 1, right? And if otherwise, like it is less than 0.5, then or equal to 0.5, then the prediction is 0. So this is kind of an approximation function we can use. Approximation function. So talking about like how we can use linear regression for classification, we can find the best fit line, and upon getting a prediction value, we can just wrap it inside an approximation function. We can get a final prediction values. But you know what, there is kind of drawback with this particular strategy, and so this is basically one way of doing it. And what we have done is convert linear regression into a classification problem, into solving a classification problem, right? So what recapping just whole stuff, revising complete thing, which is so we have the data point, we find the best fit line, and just having our predictions, we can wrap it up in an approximation function, and then we can easily get the classifications, right? So either 0 or 1, we'll be able to get the classification. Okay, so now there are some issues with this. Let's see what are these issues with this particular analysis, with this particular algorithm. What are the issues? I won't be going on to the next page. We will be analyzing it over here only. So you know what, if I suppose if we take an example. So if what we do is we just add a few number of data points over here, some data entry points over here, which are kind of extreme points, or you can say the outliers. So we are just adding a few outliers. Now what would happen would be, what, can you guess what would happen? The best fit line, this best fit line would change to somewhat like this. So this would be our new y dash, or a new best fit line. This particular line would be the new best fit line, just because adding a few data points, which are kind of extreme data points, outliers, which we generally call in machine learning terms, would change the complete the best fit line to a new best fit line, which will give a new X prediction. So this the middle mark would change, right, which would just change our 0.5 value. Okay, so while revising, I'll be telling you like what is 0.5 value. We have not covered that one, but yes, so that would completely change our complete model. So just think of this like adding a few training data points, which are kind of an extreme data points, would change the complete model. Okay, I mean, like, this is not, this should not happen, right? So suppose you have kind of two classifications, so you need, so okay, fine, so let's draw it in a neat way. Fine, so let's just recap it, like what all has happened till now. So you had this kind of data. If we plot it graphically, so the data would look like this, right? And you had this best fit line, but on adding a few outliers, kind of these values, your complete data line just shifts. And currently you were having an approximation function, which was the y predicted is greater than 0.5, so prediction would be 1, otherwise prediction is 0. This was kind of an approximation function you were having right now. So what you were actually doing was you were making a cut on this 0.5 value. This 0.5 value, you were making a cut, like whatever the prediction comes, if the prediction is greater than 0.5, whether it be any value, we'll be talking about this issue as well, whether it be any value, you just decrease it down towards like 1, and you know what, if it is less than 0.5, just make it 0. So just by adding a few outliers or extreme values, your whole prediction curve changes. And see, this should not happen, right? So one thing, in this video I have talked about is this best fit line, or what we call it as a decision boundary. So this is known as a decision boundary. This is known as a decision boundary, right? These decision boundary, this is a line deciding the classification. This boundary can be one-dimensional as well as it can be two-dimensional boundary. So suppose you have suppose you have two classifications, binary classification, right? So in this binary classification, you have this decision boundary, or even adding some few outliers, you have this kind of a decision boundary, right? So what you can do, so this decision boundary is a 1D decision boundary, and in the case of binary classification, you get a 1D decision boundary, right? And this is a linear decision boundary. You can see the line. This is a linear decision boundary. We would be calling it DB, right? Linear DB. So it is a linear decision boundary. And in another way you can have it is like, suppose you have this and you have some data points here and you have a few triangles over here, right? So you can just have this decision boundary, right? Maybe somewhat like this. This is kind of a decision boundary you can have. But if we talk about a 2D decision boundary, that could be in a case where you have data like this. So you have these crosses on the exterior part, right? And then these dots are, so suppose cross represents 0 and dot represent 1. So on the outer side you have 0 and on the inner side you have 1. So there you can have a non-linear decision boundary, or a 2D decision boundary, right? This is a kind of a non-linear decision boundary. And see, with the simple with the kind of these algorithms like logistic regression or linear regression, you can't actually achieve these non-linear boundaries or decision boundaries. But yes, moving ahead with these videos, we'll be understanding like how you can actually plot these decision boundaries, kind of non-linear decision boundaries, and just we'll be talking about overfitting the decision boundary in our data. And moving forward, we'll be looking about these things. So ending the video on this note, we'll be further talking about the classification algorithms and specifically logistic regression in few next videos, right? So that's all for this video. I hope you would have liked the content of this video. If you have liked the content of this video, then please hit the like button, subscribe the channel, and comment down if you have any queries, or if you like how you like the video. Please give honest feedbacks. I really appreciate that. Thank you.